What if time could run backward, not just in movies but in reality? Could a shattered cup reassemble itself? What if I told you that some of the most brilliant minds are questioning the most fundamental rule of our existence, time's one-way street? It's a concept so deeply ingrained, we rarely stop to consider it. We experience life as a linear journey, a sequence of unstoppable moments unfolding one after another. One thing happens, then the next, in a relentless chain of causality. A glass shatters, but never reassembles itself. This is the universe we know, governed by the unwavering principle of cause leading to effect. This powerful, intuitive sense of forward momentum is what physicists call the thermodynamic arrow of time. It's the reason why order descends into chaos, and why the past is so distinct from the future. It's the invisible current, carrying us from cradle to grave, with no apparent way to turn back. But is this arrow truly unbreakable? But here's where the mystery deepens. At the quantum level, the fundamental laws of physics don't care about the direction of time. This is known as time reversal symmetry. Imagine filming a collision between two subatomic particles. Whether you play the film forward or backward, the events are equally plausible according to the equations. The math works perfectly in either direction. So if these fundamental rules are time symmetric, why does our macroscopic world have a one-way arrow of time? We never see a shattered glass reassemble itself, or a puddle of water unsplash back into a cup. Our reality is relentlessly directional. Somewhere between the micro and the macro, the universe's preference for a one-way journey emerges from these time-neutral laws. This transition from symmetry to asymmetry is one of the biggest unsolved problems in physics, and the key to unlocking the true nature of time itself. So, where does the relentless forward march of time's arrow truly come from? Why does time only flow in one direction? The most compelling answer science has is a concept called entropy. It's a fundamental way of measuring the amount of disorder, or sheer messiness, in any system. To understand this, just think about your bedroom. There are countless ways for it to be messy. Clothes on the floor, books out of place, but only a few ways for it to be perfectly tidy. Left to its own devices, it will always tend towards a state of messiness. It takes deliberate effort and energy to clean it up. The universe operates on the same principle, just on an unimaginable scale. It's like a giant bedroom that began in a highly ordered state and has been getting messier ever since. This unstoppable progression from order to disorder is a cornerstone of physics, the second law of thermodynamics. The arrow of time is the arrow of increasing entropy. The universe began in a surprisingly orderly, low-entropy state. Over billions of years, it has expanded and become more disordered, driving time forward. The past is order, the future is chaos. The second law of thermodynamics applies to total entropy, but it doesn't forbid local decreases. Your refrigerator cools the inside by pumping heat out, increasing the total entropy of your kitchen. So, could we create a tiny, local pocket where time runs backward as long as we pay the entropy price? Scientists are running experiments to find out. This idea is called the Loschmidt echo. While reversing trillions of gas particles is impossible, scientists can do something similar in quantum mechanics. With just a few atoms, a carefully crafted electromagnetic pulse acts as a reversal kick, causing the system to evolve backward and return to its initial state. These aren't science fiction. Researchers created time echoes with atoms and qubits, watching nature run backward for a fleeting moment. But the system is extremely small, isolated, and the reversal is temporary, requiring huge external control. This increases the lab's total entropy, so the second law stays unbroken. So, if we can nudge atoms to retrace their steps, what kind of inventions could this lead to? The most promising tool is the quantum computer. Using qubits, which can exist in multiple states at once, they can perform calculations impossible for classical supercomputers. This makes them perfect simulators for the quantum world, a kind of VCR for rewinding complex molecular interactions. A quantum computer can build a perfect digital twin. Because quantum laws are time-symmetric, you can program the simulation to reverse. It's like a VCR for quantum reality, with big applications, designing new materials, drugs, and even debugging quantum computers by restoring qubits to their pristine state. Quantum computers give us an unprecedented window into nature's workings. They provide a sandbox to explore quantum what-ifs, turning time reversal into a practical tool. We become choreographers of the quantum dance, directing steps to debug quantum systems or design new materials. Another concept uses artificial intelligence. AI models are becoming astonishingly good at modeling complex, chaotic systems, learning the patterns of everything from weather systems to financial markets. Imagine an AI that models a physical system, allowing us to simulate its reversal. An AI could watch a system evolve, learning its rules with incredible precision. With that knowledge, it could calculate the exact actions needed to reverse the process, guiding every particle back to a previous state like a perfect choreographer. These three distinct fields are converging on a single profound truth. We are on the cusp of learning to control our own time. This leads to a massive philosophical question. If we could reverse a significant event, would we be erasing history, or are we doing something else entirely? Truly changing the past would create impossible paradoxes and violate causality. So instead of erasing history, a time-reversed event might exist in a small bubble of reality, a pocket universe that mirrors a moment without actually changing our history. This opens up a universe of speculation. Would these reverse processes be stable? Could we interact with them? The ethical questions are just as profound. Who would decide what gets reversed? While humanity is nowhere near ready for this power, for now, time marches on. But we should never forget that we live in a universe far stranger and more wonderful than our everyday experience suggests. The quest to understand the arrow of time is a journey into the heart of our strange and wonderful universe. Don't forget to like and subscribe for more discoveries on Invention Chronicles. We leave the arrow mid-flight, its glow in silver and copper. Until we meet again, follow its whisper in the quiet. Thank you for watching, stay curious, and keep exploring the world of invention and discovery.